before we get started today, maybe go over what our agenda is going to be. We're going to try to keep this to about 30 minutes, and most of that's going to be looking at actual project data. So the PowerPoint should only go on for a couple more minutes here. Before we get into that, we'll go over just a little more about PMC, kind of what we do and what our background is, in particular in reality capture and modeling. Then we're going to jump into kind of defining what I mean when I say working in a hybrid environment. Basically, that's mixing point clouds and CAD data and any other data we can get into one environment to accomplish project objectives. Then we're going to actually get into real projects. So we're going to start with, these are all going to be small projects, specifically picked for being small, so they're a little easier to get to the details of. We're going to start with a steel detailing project that's actually only 3 scans. We're going to then look at a project where a large heat treat furnace is being fit into an existing location. They're then going to move into a new major equipment planning, press bay, and kind of what went into looking at that and comparing existing conditions to new things that are coming in. I said a little more about us. We've been scanning since around 2003. In that time, we've obviously done a lot of projects. Back in 2015, we roughly crossed the line of about 250 million square feet that we've scanned. That's somewhere around, we've added about another 100 million since then. And we do everything from, like I said, very small projects. It can be as little as a single scan up to extremely large projects that can be 5,000 or more scans. So let's go kind of what it means to work in a hybrid environment. Like I said, what I mean by that is we're going to mix point clouds, photogrammetry, any kind of reality capture data, along with any kind of CAD data we can obtain, whether that's 2D, 3D, PDFs, old drawings, anything in between. So, we might use it to mix prototyping for rapid prototyping. In this case, what we're looking at is, although it looks like a photograph, this is actually in this case, like a true view. This is a new mezzanine, new platform inserted into an existing facility, allowing the owner to get a chance to look at what this is actually going to feel like inside of their facility. Here we have some examples where we're actually projecting ceiling grids into the web-based point cloud. So obviously what we're seeing in the image existed, but the ceiling grid did not. This is great for ongoing facility maintenance after the site is closed up. This is about as traditional as it gets in our workflows. This is collision detection and coordination. You're looking at fabrication level geometry mixed with point clouds. Another thing would be kind of validating construction. So this is making sure everyone on the project team is building to the model like they said they would. And this is being done live during construction. Steel fabrication and detailing, we're going to look at that in a little more detail in a second. Bringing scan data directly into drawings, so we can integrate this into not just planning and not just coordination type views, but point clouds can actually push straight out to a project deliverable. And then just one last quick one, pre-pour verification. Again, this is similar to construction validation, but a little more domain specific, where we're really trying to validate what's been laid down before the concrete gets poured. So that we're going to actually jump into live projects, starting with a small steel detailing project. So what we're looking at here is actually an existing location, obviously that was scanned. It's only 3 scans, and all we were doing was filling this pit in the middle with some new steel. In this case, PMC was actually doing the steel detailing work. We do this on small projects for specific customers. It's really not a core business, but we do it. So what we wanted to make sure was this is a complicated, despite it being small, complicated existing facility with some pretty rough conditions, as things have been demoed out over the years and not always cleanly removed. So to give you an idea, if we shut off the steel here real quick, this is exactly what was out there on the day that we went out to scan. Anywhere you see these circles is where a scan was set up on the floor. And you'll see in this one there's a lot of areas where there's some shadowing and things, and it's because this just didn't need to be scanned that much. Again, 3 scans. This took all of about 15 minutes to get the scan data complete. All right, and now we have something to work with. So then we come in and using your traditional engineering design drawings, we've come in and we've created the actual fabrication models that will be used to generate the fabrication sheets that will get all the steel made. So in all of these, what we're doing is, you'll notice a common theme. We're not modeling what is existing, especially what is existing to remain. There's just no need to model. And this really allows us to catch things that would be extremely difficult to model, including things that are even somewhat hard to see in the scan. It's a little challenging to see, but there is a break line of an existing floor slab along this wall, where the existing slab has been removed and demoed out. The original design called for these spreaders to be put in right on that breakaway. That wouldn't work. You would not want to try to drill in and lag these L brackets to that existing rough surface. Easy enough to see in the point cloud, and a quick design change to add a little piece of 4x4 square tube just to offset it a tiny bit and get them down to clean poured concrete. Also, as we kind of continue down the wall, there's a lot of little details we can make sure we're not going to run into. So, for example, we can make sure we're not going to hit this unistrut, we're not going to hit these conduits, and all these things were collisions in the design documents, and were then taken care of in the fabrication process. And kind of as we go down, you can see each little thing was missed. As we get over here, this middle pipe actually did not show up in any of the design documents. It was something new that had been installed. So very, very easy for us to fix. It's just part of the fabrication work that we were doing. As we come around, we look through some more of this. This large girder going down the middle had a very, very rough top on it, including some cutaways where beams had been welded and then had been torched off. There's one shown right here. A little hard to see in the point cloud, but we can make sure we're not going to hit that with any of our new steel, therefore saving the time of having to break this off and grind down the welds. We can just shift beams, an inch here, an inch there, and make sure we're not going to hit it, all to eliminate field work. In all these cases, we're trying to offset field work with digital work in the computer. I said this is a very, very small project. 15 minutes of scanning easily eliminated many, many, many hours of extra field work. We'll jump into our next project. This one takes a little more detail in the point clouds, takes a little longer to show up. But what we have here is a heat treat furnace, seen in white. There's actually 4 identical furnaces that have been installed over the years, 1 per bay in the building, going all the way down this column line. And in each case, what they had done is they had removed, you can see it in here, they had removed the existing roof, stubbed up the columns, put in new trusses, new framing, all because they were concerned about clearance heights for the removal of a filtering tube out of the furnace. In this case, these blue things are what we're looking at, and these need to be lifted vertically out of the heat treat furnace and then transferred out to the aisle for servicing. So what we're able to do in coordination with, combining scanning with contacting the actual manufacturer of the furnace. So this is the actual furnace that would go in. It's not a rough approximation. It wasn't redrawn. This is taken directly from the fabrication package of the manufacturer. We combine that with the exact specifications for the bridge crane that would be used to remove the tube, and then work closely with the structural engineer to develop a plan that involved cutting out the bottom quarter truss, raising it about 1.5 feet, and reframing it back in. All that combined, we are then able to prove absolutely that there is clearance to remove these tubes and slide them over. This is all facilitated really by working in kind of these hybrid environments. Now you could actually have taken this and you could model it all, but when a building owner sees this new crane and we are actually able to move things live in the model, they're able to really visualize it and develop a level of trust in what we're saying. Versus if you do this all in a model that's not really detailed, sometimes the owner will still question what you're saying and whether or not you can actually deliver what you're promising to deliver. But when it looks like reality and we can show them that we've done all the work and we've modified everything and drawn everything correctly, you can achieve that certainty that gives them basically the good feeling to move forward and not risk production or risk project delays. So this is a very powerful example that saves an incredible amount of money. Again, this is a very small scan project. This is 1 day's worth of scanning, a couple days worth of CAD work, and the end result is that you end up with a model that's exactly correct to what's going to be put in. And for our last project we're going to move on to, this one's a little larger and a little more complicated. This is what is today actually, getting very, very close to being a complete press bay. So a very, very large industrial press going in here right in the middle. You can see all the framing coming in for it. And here again, we're doing relatively simple scanning, but we do have a upper and a lower level that was scanned. This was scanned during construction, so the pit's been put in. One of the things we're able to do is verify that, in fact, all the press piers are in the correct location as designed. And when we have specifics like that, we can get down to about 1/8 of an inch accuracy and know that they are, in fact, matching what was designed. We then take this scan and we locate it to the facility data that exists, the CAD data that exists, and we start usually by bringing in just the engineering and architectural data. So we're able to take a look at this and we start looking at, is the design functional? So we're not looking necessarily at details, but we're looking at the overall design and is it going to fit? Are we going to be able to fit ductwork in where we want to fit it in? And then as the project evolves and progresses, we're actually going to start adding in the real fabrication level information. So what we're looking at now is not engineering data. This is fabrication level data. So the ducts are coming out of Fab MEP. The steel is coming out of, I believe it was Tekla on this project. And here's where we're going to get into the real nitty-gritty of this and make sure that nothing is colliding, that everything's working well with the design. Okay, and we're going to track this over time. This is the actual coordination meeting or model that was taken to meetings. So let's go through some of the items that were picked up. These are all things that are very difficult to get correct if you're doing manual modeling. So a big concern of this is this underneath this mezzanine, this platform, where all of the new utilities for the press, all the new control systems need to go. In particular, there's a lot of cable feeds and air feeds that need to pass through the floor of the platform to connect up. And in this case, they wanted to reuse most of the platform with some new framing. So you can see here is that they've missed all the tie bracing under the platform. This is 3x3 angle bracing that runs under the platform, and it was missed. And in some cases it doesn't matter, but in other cases right here where we can see up through, this was a planned opening for tray and cables and air lines to come through. Another very common one, this one's again, I apologize, some of these are a little hard to see, but this is a C channel right here that was modeled, an existing C channel, and the person who modeled it just rolled it the wrong way, so the toe is pointing the incorrect direction. And again, what we have is we have a planned opening that's now about 3 inches smaller than what it was expected to be because all these C channels were put with the wrong roll on it. And what we actually discovered when we looked into this is that one C-channel at the end is rolled 180 degrees to the rest, and when field notes were taken, that's what was trusted, and they were arrayed down in a set pattern. So another big concern in here is the new crane that was going in and whether or not it could fit and whether anything above the crane needed to be removed. So in this case, the only thing we had available was 2D CAD drawings for the crane, so it has to be converted over into a 3D model. Even though we can work in sections, it's a whole lot easier to do this in the 3D model. And we can actually come in and we can move the crane back and forth through its travel and see if we have any clearance issues the whole way along. We did find some small discrepancies in the steel where things weren't quite lined up. They were off by about an inch. We are able to verify that things such as the pads for the steel are in fact in the correct location and that they're going to fit. This post is right in the middle of a scrap conveyor that needs to come through here and obviously needs to move. We have, this is an interesting story. So this is, in red is the bus, the new bus that's being put in. And what we found out after we came out and scanned was that, in fact, the electrical company, the electrical subcontractor, had been out here with a lift for 2 days manually measuring the site to ensure that their electrical components were going to fit. We achieved better data in 1 day and did not need a lift. And even though they came out for 2 days, they still have issues down here. And what's not shown in their model yet is a large termination box that needs to exist somewhere down here and is clearly not going to fit with these pipes that are existing today. So even with, hiring a lift and paying 2 people to be out there for 2 days, they're still not capturing anywhere near the data that you're getting with the scan. We're also able to really get into details of exactly what is removed, what's not. So here we have another cross brace. This time it's coming off a column and going to a truss. This brace is not being removed. And you can obviously see we're now inside of the duct and we can see the brace passing straight through. We can come in and we can look and we can see where the slab was actually removed versus where the steel fabricator believed it was removed. So they believed it was cut all the way back to here. You can see the back plane of their plate that they're going to anchor their tie bars onto. The reality is the slab had only been cut back this far. So this, the resolution to this is either to cut the slab back or move the steel, depending on exactly what's coming in. As I was mentioning earlier with the furnace, we always try to work with real fabrication data. Although we can work with the engineering data, working with the actual fab data is always going to be preferred. In this case, we were in the process of bringing in the fabrication models for the presses that you can see in here. And we were able to look and find out that things that were expected to line up did not. So in some cases we're combining point clouds, but in other cases we're just combining pure model geometry. And so out here you have a support for the feed conveyor, which is just going to sit on the slab. Less desirable, more desirable would have been for it to have sat on the steel. This allows us to catch these types of things and make corrections to them in the virtual world before we get into real concrete and real steel.